Hey class, it's Mr. Fallstrom, and right now we've been doing a lot of different practice with fractions. We spent a lot of time lately on finding common denominators, and we've also spent time learning how to rename fractions. And I just want to give you this message. If you're understanding it and it makes sense, that's great. But if it's not making sense to you, if it's confusing, I just want you to know that that is completely normal in 5th grade. I've been teaching 5th grade for 7 years now, and every year I've taught it, there are always students that are smart, where when we get to fractions, it confuses them. And that doesn't mean that you're not a smart person. It doesn't mean that you're not good at math. It just means that this is new and that everybody is different. Some people pick, it has nothing to do with how smart you are or anything like that. Some people can be very smart and it takes them a long time to figure it out, and that's okay. Some people pick it up quick. It has nothing to do with you. The main thing that you need to do, if it's not making sense, is you can control what you're doing in class. So make sure that you are doing the practice problems. Make sure you are asking questions. But if you keep practicing and you really want to learn it, you will learn it. I promise you. Don't feel like you're the only person in class that doesn't get this. Because I look at everybody's work and I can tell you right now, believe me, there are a lot of people in class. There are many students that every year that this is difficult. So I just want to give you that message. I want you to feel good about yourself. Even if right now you don't feel good about this, you have to give yourself some patience. Okay? You're going to have to work hard, but you can do it, and it's going to happen. I want to make this video because I want to try and help people that where some of this stuff isn't making sense. I think common denominators for most people are making sense on how to find it, but it's the renaming part that I think is throwing people off, especially the multiplying part. Like, I think some people don't understand why we're multiplying the fraction to rename it. Some people don't really understand how we multiply, or why do we multiply both parts. How come we're multiplying the bottom number and the top number? It doesn't really make sense. So I want to just kind of see if I can make that, make that light bulb come on over your head and see if that this will help you. So I'm just going to take a simple fraction. I'm just going to take 1/2. Let's say we want to rename it with a denominator of 6. Okay? So I'm actually going to show you with a picture how this works. So I'm going to draw my hole. And I'm going to show 1/2. So I have my one hole. It's going to be cut into 2 equal parts. And I'm going to shade one of those parts. So here's our 1/2 piece. Right now there are 2 total pieces in the hole. I want to have 6 total pieces in the hole. So if I only have 2 pieces, what am I going to have to do to get more pieces? And if I want to get more pieces, I'm going to have to break these pieces up into smaller pieces to get 6. So what I'm going to do is, if I want 6 total pieces, I'm actually going to have to break each piece into 3 pieces. So now I've broken each piece into 3 pieces, and now we can count 1, 2, 3, 4, 5, 6. So now I've got my denominator 6. How many pieces are shaded now? At first there was 1 of the half pieces, but now if I count the 6 pieces, I have 3 6 pieces. So what I did here is, really, when I drew these extra lines, I was multiplying, because I was starting with a smaller number and I was breaking it into more pieces. I was making this number get bigger. When we multiply, things get bigger. So what I did here is, if you kind of look at this half piece, I had 1 piece, I multiplied it times 3, right? I drew those lines. Now I've got 3 pieces. I had 2 pieces in the half. Well, now that I broke each piece up 3 times, I have a total of 6 pieces in the whole. So that's why when you multiply, you're multiplying. When I drew these lines, I'm affecting the numerator and the denominator. When I drew those lines across, that changed how many pieces I had. It also changed the total amount of pieces I had, and that's why you're multiplying by the same number. So you can do this with any fraction, and you can multiply with any number you want. So for example, let's say I want a denominator of, we'll keep a half. Let's say I want a denominator of, let's do 15. No, not 15. Let's do, let's do 12. Let's say I want to turn 1/2 into 12ths. Okay, so it's the same thing. Here's my whole. I'm going to break it into 2 equal parts. I'm going to shade one of the 2 parts. So right now I've got 2 total pieces, but I want to break these into smaller pieces so that I have 12. So how many times am I going to have to break? How many times am I going to have to break each piece up to get 12? Well, if you know your times tables, you already can kind of see that, hey, 2 times 6 is how you get to 12. So in other words, I'm going to have to take each of these pieces and break them up into 6 smaller pieces. So I'm going to try and show that. So there's 1, 2, 3. It's gonna be close. It's not perfect, but that's okay. All right, so let's count here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I've got 12 total pieces. How many pieces are now shaded? So this is my shaded side. This was 6 pieces. So again, when I multiply this by 6, I also broke this up the same way. Both pieces got broken. The total thing got broken into 6 parts. So now this is turned into, instead of 1/2 piece, this is now 6 out of the total 12 pieces. So that is why when you multiply, we've changed the amount of pieces, and we've also changed the total amount of pieces, but they are equivalent. That's this equal sign right here. That 1/2. If I drew the same thing right under it, okay. If you compare these, that 1/2 is just as much as the 6/12. It's the same size whole. You're going to pretend that my drawings are completely perfect and equal. So that's why you're multiplying. We're changing the number of pieces, and to get more pieces, you have to multiply. Multiplying. When you multiply numbers, you get bigger numbers. We want more pieces. That's why it works. So we'll end with just a simple problem that we've done before in class, but just, hey, 1/2 plus 1/3. We're not able to add these right now because the denominators are not the same. We need a common denominator. So really quick, I'm just going to write down my denominators. I'm going to write down the multiples. So I'm going to start with the denominator 2. I'm just going to count by 2s. 2, 4, 6, 8, 10, and I'll stop. And then I'm going to write down my multiples of 3. So 3, 6, 9, 12. And I'm going to stop already because I see that in these both lists right here, both these numbers have 6 as a common multiple. And common multiple is basically the same thing as a common denominator. So right here, I want to take 1/2 and 1/3, and I want to rewrite them rename them into 6ths. So again, here's my half piece. We did this one already. If I have 2 total pieces, but I want 6, that means I'm going to have to break it into each piece 3. I'm going to break the whole thing up into 3 times 3. So 1/2 is the same as 3/6. Again, if I'm multiplying this by 3, that's how I would get 3/6. And why did I multiply by 3 again? I took the whole thing, I broke it, I drew those lines that broke each piece into thirds. That's where that 3 comes from. And so 1/2 is the same as 3/6. And now 1/3, I want to rename 1/3 into 6. So again, let's just draw our hole. Let's show a third. So I've got 3 total pieces in my hole, but now I want to have 6 total pieces. What am I going to do? How many more pieces do I need to double the amount of pieces, right? If 3 times 2 is 6, then that means I want to take each of these pieces and break them. So I want to break them twice. So now I've taken them, I've broken them into, see what I mean? I just doubled the amount of pieces times 2. Now I've got twice as many. And now you can see that 1/3 is the same as 2/6. I have 6 total pieces. The original 1/3 piece has been broken twice. 2 of them are shaded. And again, since I broke the total amount of pieces by 2, I also did the same thing with the numerator. That also was times 2. That's why I have 2/6. So these 2 problems are the same problem. They both, this is the amount that's being shown here being added together. This is it's the same amount right here. I've just rewritten it differently. Right, so when I had that original 1/3, that 1/3 is the same as the 2/6. They are the same amount. That's why when we rename them, now it's easier to add, because I can say, hey, I got 3 6 pieces plus 2 more 6 pieces. Now I've got a total of 5 6 pieces, and I've been able to do the problem. So if you're not really sure why we do it, or how it works, maybe I know that you might not want to do that, but honestly, having a piece of a whiteboard or something like I have, and trying to actually draw the fractions like I am and trying to break them, drawing pictures is super helpful. I know that a lot of people think math is you're just writing numbers. I would honestly try and draw some pictures out as you do this, and practice drawing the fractions and breaking them up, because that is actually a really good way to help this make more sense. And I know that it takes longer to do that, but it does help. It really does. So if you're not able to just see that, hey, I'm going to multiply, if you can't just see that multiplying thing, try drawing it out and try and figure out how many times am I going to have to break it up to get 6 parts. And I think that will help you. Let me know if this video made sense, or if you need more help. If I confused you, I would like to know. That's the last thing I want to do. I don't want to confuse you. So, if there's anything that you need me to go over with, that's why I'm here. Let me know.